Hello everyone, my name is POOJA RAWAT and I am pursuing research work under the supervision of Dr. A.L. Saroz from Department of Physics, Banaras Hindu University. The title of my presentation is AC Conductivity and Ion Dynamics Behavior Study of PVA-based polymer electrolyte films. The outline of my research work are introduction, in which I will discuss about electrolytes, motivation of my work, and then the materials used in my work, the sample preparation and result and discussion, and at last conclusion. Now starting with the electrolyte. An electrolyte is an electrically conductive medium that conducts electric current by means of transportation of ions between the cathode and anode. It is a key component of electrochemical devices. Now, the requirement of an electrolyte to be used in electrochemical devices are: first one is it should have high ionic conductivity, it should have wide electrochemical stability window, and it should have high chemical and thermal stability. It should be chemically inert with the other components of the device. It should be safe, non-toxic, and economically affordable. Now, liquid electrolyte attracts many researchers due to its high ionic conductivity, but various problems such as leakage, portability, corrosion, thermally unstable. These problems limits the use of liquid electrolyte. The best alternative to liquid electrolyte is solid polymer electrolyte because of its following advantages, such as ease of processing, good interfacial contact with electrodes, good flexibility, lightweight, free from leakage, good mechanical properties, low electronic conductivity, and so on. But still, we have seen that its low value of ionic conductivity at ambient condition limits its use in practical application. Now the question arises, how can we increase the ionic conductivity of these polymeric electrolyte systems? There are various ways to increase the conductivity of the systems. Some of them are: first one is addition of inorganic salt, varying the salt concentration, copolymerization, blending, addition of ceramic fillers and additives, and plasticization. In my present work, I have used the first method to increase the ionic conductivity of polymer electrolyte system, that is the addition of inorganic salt. The motivation of my work is to prepare PVA and X weight % of LiBF4 based polymer electrolyte films, where X is equals to 0, 15, 20, 25 weight % of LiBF4, and characterize them to find out the best optimum composition suitable for its practical electrochemical application, and to measure the ionic conductivity of these prepared samples, and then to study the AC conductivity and temperature dependent conductivity, and to study the dielectric permittivity and electric modulus of these samples. Now, materials used in my present work is PVA, polyvinyl alcohol, that has been chosen as the host polymer in this work due to its following applications: that its chemical stability, easy processability to form film, presence of high population of OH group with its side change, high dielectric constant, high charge storage capacity, and its non-toxic biocompatibility and biodegradability. Now, the inorganic salt LiBF4, that is lithium tetrafluoroborate salt, which has been chosen because of its low lattice energy. And DMSO, that is dimethyl sulfoxide. Now, in this work, we have used DMSO as solvent rather than the water, Because the ionic conductivity for DMSO cast PVA film is higher than that of pure PVA using water as the solvent. Now the sample preparation. PVA plus X weight percent of LiBF4 based polymer electrolyte films were prepared by using solution cast technique. In this method, desired amount of PVA and LiBF4 were mixed together with DMSO solvent, and then this mixture was kept in oven at 50 degrees centigrade for 24 hours to swell. This swelled solution was stirred continuously at 70 degrees centigrade until an homogeneous viscous slurry was formed. Now then, this homogeneous viscous slurry was poured into polypropylene petri dish and allowed to evaporate at ambient temperature. And finally, freestanding polymeric film was obtained. Now moving ahead to results and discussion. First one is ionic conductivity study. Now this is a Cole plot for PVA plus 25% of LiBF4 film at 30 degrees centigrade. This plot shows two well-defined regions. First one is at high frequency semicircular arc, which is associated with the bulk conductivity, and the low frequency spike which is attributed to the electrolyte polarization effect at the interface. Now the bulk conductivity is calculated by the following relation: sigma b is equals to 1 upon rb into t upon b, where t is the thickness of the sample, b is the contact area of electrolyte interface, Rb is the bulk resistance which is obtained from the intercept in the real impedance axis. Now the sample PVA with 25% salt shows the optimum ionic conductivity, which is of the order of 10 to the power minus 5 Simon per centimeter at 30 degree centigrade. For AC conductivity study. AC conductivity study reveals the transportation of charge carriers of free ions as well as interaction between additives and the functional group of polymer. The figure shows two well-defined regions. First one is frequency-independent plateau region that gives the bulk conductivity of the sample, and the higher frequency region in which conductivity increases with the frequency. While the plot D, which is of 25% LiBF4, LiBF4 shows three reasons at higher temperature, which is due to and which also include lower frequency reason that arises due to the polarization effect. AC conductivity spectra is explained by Johnson's power law, given as sigma omega is equals to sigma dc plus a omega ki power n, where a is the temperature dependent parameter, omega is angular frequency, and n is the power law exponent. Now temperature dependent conductivity study. Okay, this is the plot of temperature dependent conductivity. In this plot, a straight line is observed which shows Arrhenius type behavior, and the relation is given by sigma dc is equals to sigma naught e to the power minus ea upon kBt, where sigma naught is the pre-exponential factor, ea is the activation energy, kb is the Boltzmann constant, and t is the absolute temperature. Now the activation energy is calculated from the slope of log sigma versus 1000 upon T plot, and it is found that the activation energy is minimum for 25% LiBF4 based film and its and the activation energy decreases due to activation energy decreases with the increase in salt concentration due to increase in amorphousness. Also, the conductivity increases with the rise in temperature because the fraction of free volume of electrolyte system increases with increase in temperature, which promotes the charge carrier to move freely in the polymer matrix. Thus, we can say that the conductivity increases as temperature increases. Now, this is the table which shows in which the value of conductivity and pre-exponent factor has been listed. Now, dielectric permittivity study. The figure shows the variation of dielectric constant and dielectric loss with the frequency. From figure, it has been observed that the dielectric constant and dielectric loss, dielectric loss at low frequency have higher value, which is due to the electrolyte polarization effect, and at high frequency the dielectric values decreases because the dielectric relaxation phenomena is dominated at high frequency region. Now, electric modulus study. Small values of m dash at lower frequency regions reveals negligible contribution of electrolyte polarization effect, and with frequency the value of ms increases, which may be due to the bulk effect. Now, the long tail at m dash long tail at low frequency of m dash plot is due to the large capacitor related to the polarization effect. Now, the temperature and concentration dependent dielectric permittivity study. From figure A and B, which shows the concentration dependent dielectric permittivity study. With increasing concentration of salt, dielectric permittivity increases due to large number of free charge carriers at the electrolyte interface. Now, dielectric permittivity increases with the increase in temperature, as that is shown in figure C and D, and this is observed for the polymeric for polar polymers. Now, the conclusion of my work is PVA plus X weight percent LiBF4 was successfully prepared by using solution cast method, and we have optimized the sample. The sample PVA with 25 weight percent salt shows optimum ionic conductivity, that is of the order of 10 to the power minus 5 Simon per centimeter at 30 degrees centigrade. Now, the AC conductivity spectra of prepared polymer electrolyte films at different salt concentration as well as different temperature for PVA plus 25 weight percent LiBF4 follows the Johnson's power law with n less than 1. Now, temperature dependent conductivity follow Arrhenius type behavior. The electrode polarization and strong coupling between the free ions and segmental motion of the polymer chains were observed in dielectric permittivity study. Thank you everyone for your kind attention.